So there are three different forms in which we can write linear equations. One of them, why don't we click them all closed? Click all the Chromebooks closed and everybody focus up here. So one form is called standard form. Do you guys remember what that is? That's it. AX plus BY equals C. Very good. Oh, don't want to do that. I want to do this. Yeah, AX plus BY equals C. So this is a form that we like to use when we're dealing, for example, with linear systems. Okay, it's nice to write the lines in standard form. Typically when we're using like matrices and matrix math to do linear algebra with big systems of linear equations, this is the preferred way to do it. And we'll actually see some of that fairly soon. When you write a line, an equation of a line in standard form, there are three rules we have to follow, three important rules. So the first one is that A, B, and C have to be integers. They cannot be fractions with non-unitary denominators, meaning the denominators can't be anything other than 1. Okay? They can't be decimals. They can't be irrational. They are integers. Okay? That's one thing. What else? Rule number 2. This is kind of a soft rule. This one is sometimes we don't, like different textbooks wouldn't, some don't even use this rule. But typically we say that the leading coefficient, so A, has to be positive, has to be greater than or equal to 1, although that one isn't always such a big deal. Third one is, though, the GCF, the greatest common factor of A, B, and C, needs to be 1. Okay, so let's practice putting a few equations into standard form. So what about number 1? What's the only thing I have to do to put number 1 in proper standard form? The way it is, honestly, it's probably not too bad. But if we're going to follow those three rules strictly, what do we have to do? Yeah, I got to multiply by -1 because it's violating rule 2, isn't it? A is negative. So all I'd have to do is take this thing and multiply through the whole thing by -1. And if I do that, it's just going to change all the signs. So I'm going to get a positive 5x minus 6y equals positive 12, and I'm done. What about, like number 2, all we'd have to do there is we got to push the x over to the left side and then make it positive, right? So again, distribute a -1 through everything. We could either multiply everything by -1 or divide everything by -1. Same thing. What about number 3? Add 24, okay? So we add 24 and we're gonna push that 24 over there. So 9x plus 6y equals positive 24. Done? Okay, anybody see anything else? We're still breaking a rule. What do you think, Hallie? Yeah, there you go. The greatest common factor is not 1. What's the greatest common factor of 9, 6, and 24? 3. Yeah, I got to divide everything by 3, don't I? So if we divide both sides through by 3, then I'm going to end up with 3x plus 2y equals 8. There we go. Now we're good. Okay, that's a tricky one. That's the one it's easy to miss that one. What would I do with number 5? It almost looks good, right? I've got a positive value for A. If the A and the B are on the left side and C is on the right side, but what's wrong? They're not integers. Okay, so how could I make all those integers real quickly? The least common multiple of the denominators, which is what? 12. Yeah, good. I could just multiply 3 by 12, couldn't I? And if I multiply through by 12, 12 over 4 is going to reduce to a 3 times 3x, so we're going to get a 9x. Everybody agree? 12 over 3 is 4 times -1, so I get a -4y. What do I get on the other side? 12. There you go, and I'm done. Okay, good. And then if we wanted to, like, look at this example, we'd have to just multiply through by 6, right? subtract the 6y, and I'm good. Okay. Give me 1 to 5 on that. Is that all making sense? Okay. All right, so what about another form? So we looked at standard form. Here's slope-intercept form. Okay, what is slope-intercept form? There you go. Y equals mx plus b, of course. Okay, we could write it using f of x too if we want. What is m? Mx plus b. That's the slope, isn't it? Good. And what's b? Y-intercept. Okay. So slope, remember, is the constant rate of change between the 2 points. Just think rise over run. So here's a quick reminder about our definition of slope. So slope, it's rise over run. We say it's y2 minus y1 over x2 minus x1. Now, what do the subscripts mean? When you see an x or a y with a subscript of like 1 or 2, what it's referring to is which point are we associating it with? We're going to say that point 1 is some values of x and y. These are not variables now. These are meant to represent actual numbers that we're plugging in for x and y that are going to define the coordinates of that point. So they're not a variable, they're constants. They're numbers that are constant that we're going to plug in. Same thing for x2, y2. This is point 1 and that's point 2. So if we have 2 points, we require 1s and 2s for our subscripts, okay? Okay, so give me 1 to 5 on that. You guys all remember slope, right? No big deal, okay? So there are a total of 4 different kinds of slopes. Can you tell me about the slope of that green line? It's positive, isn't it? Yeah. If the line is, oh my goodness. If the line is rising from left to right, so if an ant is moving in the positive x direction and walking uphill, that's defined as a positive slope. So what kind of slope is that? Negative. What kind of slope is that? If it's horizontal. 0. There you go. Now think why that is. If I took 2 points on a horizontal line and I calculated the slope between those 2 points with a slope triangle, how much am I rising between the left and the right point? 0. How much am I running? Well, some distance, whatever the run is. Doesn't even matter. Some number, right? So the slope then is 0 divided by a number, which is 0. Okay? How about this one? Undefined, yeah. It's undefined because, again, think of if we try to calculate the slope, think what we're going to get. If I take 2 points in going from the bottom to the top point, the rise is going to be some number. Say it's 4, right? Who knows? What's the run going to be? 0. Okay, when I try to calculate the slope, I'm going to get some number like 4 divided by 0. Well, can we do that? No, you can't divide by 0, can you? So this one is undefined. Okay, so when we want to put a line into slope-intercept form, the algebra is really simple. All you do is just solve for y, so isolate the y and simplify the other side, and you're done, right? So for example, what if we want to do number 10? Our job here is to write the equation in slope-intercept form and then graph the equation, okay? So how about this one? If I want to write this in slope-intercept form, what do I have to do? Okay, got to add 1, and what else? Yeah, there you go, right? Because I want to keep the y where it is. I want to isolate the y. In order to do that, I'm going to have to push the 4x to that side and the negative 1 to that side, right? So I end up with y on the left equals negative 4x. I had to subtract the 4x to the other side plus 1 because I had to add the 1 to the other side. Everybody agree? Okay, how would I graph this point now? If I'm going to graph a function or graph a line, really my strategy is always the same. All I ever have to do is I have to get 2 points and then connect and extend, right? Now, okay, so let's try this once and then I got a little discussion maybe we'll launch into about this a little bit. So I got to get 2 points. Where would I start with my first point? The y-intercept, which is what in this case? 1. So the y-intercept is going to be the point 0, 1. So it's going to go, so it goes right there, doesn't it? Okay, how would I get my second point? What am I going to do? Down 4 and right 1. Okay, good, because it's the slope, isn't it? The slope is -4, which is the same as -4 over 1. That's rise over run, isn't it? So from this point, I'm going to rise by -4, and I'm going to run by +1 to create a second point. And then once I've got my second point, all I have to do is connect and extend. Okay? Now let me ask you something. How many points, how many lines could go through a single point? How many lines could I draw that go through a single point? How many, in fact? How many? An infinite number, right? Even if I'm only talking about on a single plane, but really, I mean, if I draw a point in space, I could have lines that go through it that are not coplanar, right? That aren't even in the same plane. But even if I did this on the board up here, like if I drew a point, for example, right here, there are an infinite number of lines that even on the board that could go through that point. They're just going to have different slopes, right? So how many points are there, how many lines are there that go through those 2 points? How many? 1. Yeah. There's only one line that goes through 2 distinct points, 2 different points. Okay? Interesting. Okay? Interesting. How many, let's talk about dimensionality here for a second. So how many dimensions is our universe? We see things in how many D? 3D, right? Our universe is 3D. Why? What do we mean by 3D? Well, there's 3 dimensions, meaning we've got a left to right dimension, got an up-down dimension, and we have a forward and backward dimension, right? Okay, that's all we need is some combination of those 3 dimensions can specify any point in our universe, right? It's 3D. How many D, in other words, how many dimensions is a line? It's 1. Yeah, a line's only 1 dimension. Okay, so that's not very interesting. It's only got left and right, for example, if it's a horizontal line, right? Okay, so a one-dimensional object like a line requires 2 points to specify one of those. Okay, how many dimensions is a plane? Like the plane of the board. Everybody agree that's 2? And we represent that by the 2 axes, the x-axis and the y-axis. There's 2, left, right, and up, down. Okay, there's 2 different directions that are independent of each other in a plane. So it's 2D. How many points do you suppose it takes to define a unique single plane? How many planes could go through those 2 points? Well, here's one right here, the board in which they're drawn, right? But I'll show you another one. Like what if I took a plane like that plane right there and extended it? It would cut through those 2 points, wouldn't it? And I could also do that plane right there and that plane right there if it's going to cut through those 2 points. So what do you think? Infinite number, yeah. So two points is not enough. How about this though? What if I added a third plane? Now, as long as the third point, I'm going to make it a special here. I specifically make it so it's not collinear with the other 2. So the 3 points don't fall on a single line. How many planes are there that contain all 3 of those? 1, just the plane of the board. That's it. Okay, interesting. Okay, so let's see if we can establish a trend here. A line is 1-dimensional. It requires 2 points to define a unique line. A plane is 2-dimensional, and it requires 3 non-collinear points to define a plane. Okay, our space, right, our universe is 3-dimensional, So a space is three-dimensional in our universe. How many points do you suppose it takes to define a single space? 4. Yeah. If I take 3 points that are non-coplanar points, like I take those 3 points and I draw one right there, there's only one space, our universe, that will define, that will contain all 4 of those points. Okay, I'd have to have another universe to contain a point that wasn't included in those, right? Does that make sense? Okay, there's only one. I could not come up with another space that would contain those 4 points, those 3 plus that one right there. Okay, only our universe contains those 4. Okay, there might be other spaces that could contain those 3 and a point that we don't see. Okay, it's not in our universe, but our universe is the only one that contains those 4. Okay, strange concept, but that is true story. Okay, so we're talking about lines. Let me ask you this question. Have you